Welcome everyone again. So this is the second video in the series. In the first video we have written the Hamiltonian for the harmonic oscillator in the form h cap is equal to h cross omega what was that, p square by 2m, or no, p naught square plus x cap square by x naught square. Okay, now let me write it this way. See, x cap is less complicated, right? So maybe let us write it first. So x cap square by x naught square plus p cap square by p naught square. So let me write h cap is equal to square omega x cap square by x naught square plus p cap square by p naught squared. Okay, and remember what x naught and p naught was. What was p naught? P naught was root of 2m omega h cut, and x naught was root 2 h cut by m omega. Okay, now we are going to look at this Hamiltonian. So inside the bracket we have square of two terms, right? Maybe we can also write it like is equal to h cut omega x cap by x naught squared plus p cap by p naught squared. Okay, so this is new h cut, new Hamiltonian. Now when you see something like this, say for example a square plus b square, what do you remember? Suppose you are seeing a square minus b square, then you will say this is equal to a plus b into a minus b, right? Now how can we get a square plus b square? Is there any way? Suppose instead of b, here we have ib, and this b is ib, then what will we have in this expression? If b was ib, what do we have? Let us check. So a plus ib times a minus ib will be a square minus ib squared, right? But what is ib squared? This will be I squared b squared, but we know I square is minus 1, so that minus 1 will get multiplied with this minus and it will become plus, so we will get a square plus b square. Okay, so whenever you have something like say now a square plus b square, you can write it like a plus ib times a minus ib. Okay, or if it is something like c square plus d square, you can write it like c plus id into c minus id. Okay, now similarly, what do we have in our Hamiltonian? We have x cap by x naught squared plus p cap by p naught squared, right? Then we can do the same here also, can we? Okay, now let me write how can we write x cap by x naught squared plus p cap squared by, or we write this way, x cap by x naught all square plus p cap by p naught all squared will be what? Okay, x cap by x naught plus I into p cap by p naught. Okay, this is a plus ib. Now this times a minus ib over x by x naught minus I p cap by p naught. Okay, but when you do this, this is not what you will get. So this will not be equal to this. How is that possible? It is because this is not normal numbers, right? This is operators, so they will have different properties. Okay, however, let us try what this will give us. Okay, so let us see what it will give us. So we are going to find x cap by x naught plus I p cap by p naught times x cap by x naught minus I p cap by p naught. Okay, so now open the brackets. Let me write it here. What do we have? First term we will multiply with this one, so we will get x cap squared by x naught squared. Now first term multiply with second term, you will get this minus will come here, then I is here. Now x cap p cap. Now what is on the bottom? X naught and p naught. Okay, now take the second term, multiply with the first term, so we'll have plus I by x naught p naught, p cap x cap. See, here the order is important, right? When you multiply p cap with x cap, you know that p cap x cap may not be always equal to x cap p cap, because they are operators. For numbers, we know that AB will be always equal to BA, but here, since it is operator, so the order how it acts on functions, it does actually matter. Okay, so we cannot write x cap p cap here, so it should be in the same order, p cap x cap. Now what will be the final term? In the final term you have I into I, okay, this term with this term, so I squared. What will be I squared? Okay, let me write it like this. So there is a negative sign, then I squared, then p cap squared divided by p naught squared. Okay, now what is I square? I square is minus 1, so this will get cancelled and become plus. Now let me take this last term towards near to this. Okay, so we have x cap squared by x naught squared plus p cap squared by p naught squared plus what? Now we have plus, let me write this term first. So I by x naught p naught, p cap x cap, now this term, minus I by x naught p naught, x cap p cap. Okay, so you can also take this two constants here outside, take the others inside and bracket, so I can write x cap, this is not 0, so x cap square by x naught square plus p cap square by p naught square plus I by x naught p naught times p cap x cap minus x cap p cap. Okay, now now we have what was this? We were trying to find what will be x cap by x naught plus I p cap by p naught into x cap by x naught minus I p cap by p naught. That's what is equivalent to a plus ib times a minus ib. Okay, and we were checking whether this will give a square plus a square, but see what we have got here. This is not equal to x square plus a square by x naught square plus p cap square by p naught square, but there is an extra term which is this. Okay, so we see that here x cap by x naught plus I p cap by p naught times x cap by x naught minus I p cap by p naught is not equal to x cap by x naught whole square plus p cap by p naught square whole square. And why is that? Because this order matters. For operators, this order matters. Suppose this was just numbers a and b. Suppose if x and p were just a and b, then ab minus ba will be 0, so this term will be 0, so the relation will be valid. Okay, now what can we do? Okay, let us still forward with this expression. So let me write what do we have here now? So x cap by x naught plus I p cap by p naught times x cap by x naught minus I p cap by p naught. We have it as x cap square by x naught square plus p cap square by p naught square plus I by x naught p naught p cap x cap minus x cap p cap. Okay, now this expression, if you remember, I hope you already know, this is called commutator of p cap and x cap. Okay, so actually there is a symbol for writing that. It's commutator for p cap and a cap, we will write using the square brackets. P cap x cap is equal to p cap x cap minus x cap p cap. Okay, this is called commutator of p cap and x cap. Suppose generally commutator is defined as, suppose you have two operators a cap and b cap. Okay, now the commutator is defined as between a and b, a cap comma b cap is equal to a cap b cap minus b cap a cap. Okay, now suppose a cap b cap is equal to b cap a cap. Okay, so it means the order doesn't matter. So what will happen if if a cap b cap is equal to b cap a cap, we will have this commutator to be 0. Okay, so because these two terms will be same and we will have commutator to be 0, then we will say that that is if the commutator a cap b cap is equal to 0, we say a and b commute. Okay, so that's about commutator. So yeah, now in the expression for what we have found finally, that is x cap by x naught plus I p cap by p naught times x cap by x naught minus I p cap by p naught is equal to x cap square by x naught square plus p cap squared by p naught squared. What do we have? Minus or plus, yeah, plus I by x naught p naught. So the expression we can write it like p cap x cap. Okay, now let us try to find what will be the commutator for p cap and x cap. Okay, we know that momentum operator p cap, or yeah, here we should have already written that all this p we are talking about is actually px. Okay, because we are considering a one-dimensional system, so the momentum is only present on x-axis, so we will have px cap. Okay, we should have written this before, but still it's fine. So we have px cap. Now what will be px cap? We know it is minus ih cut dou by dou x. This is the momentum operator. And similarly, what is x cap? X cap is just x. Okay, now what will be the commutator for p cap and x cap? Or let us write, now let me call it p cap for now. It's fine, right? Remember, it's only the momentum on x-axis. Okay, because this is the total momentum we have. Now we can write it like p cap x cap is equal to p cap x cap minus x cap p cap. Now the question is, how can we find this value for this commutator? Okay, the way for doing it is that we will take some function or wave function, say wave function, then we will try to apply this and try to reduce it to a short form. Okay, so let me take a function here, say phi. So if p cap x cap is acting on a wave function psi, we will open the bracket, so it will be p cap x cap minus x cap p cap acting on psi. Okay, now we can take psi to inside and keep it near to p and near to x cap. Okay, so this will be distributed to each terms, so we have p cap x cap psi minus x cap p cap psi. Now what is going to happen is that in this term p cap will act on psi, then we will get another term. Now x cap will act on that result. Okay, and here x cap will act on psi and p cap will act on that. Okay, so here we will write minus ih cut dou by dou x of what is x cap psi? It is just x psi. Okay, here note that here also psi is only function of x. Okay, because we are talking about 1D. Now what is here? Here x cap is what? Just x, and p cap is minus ih cut dou by dou x of psi. Okay, now what can we do here? Minus ih cut, what will be this? There is two terms. This is differentiation of product of two terms, so we'll type first term into differential of second term plus differential of first term into second term. Okay, now we can take this minus and ih cut outside, so this will become plus I h cut x times dou psi by dou x. Okay, now let us open this bracket. So it will give us minus I h cut x dou psi by dou x. What is here? This minus I h cut will come here also. So minus I h cut. And what is dou x by x? Dou x by dou x is just 1. So what will be remaining is only psi. Okay, and finally I h cut x dou psi by dou x. So see these two terms, one is negative of the other, so they will cancel each other. So what is left is only the middle term, which is minus I h cut psi. Okay, but what were we calculating? We were calculating p cap x cap psi. Okay, so and we have finally got it is minus I h cut psi. So we can write p cap x cap psi is equal to minus I h cut psi. Okay, from that what can we comprehend? See, suppose the psi was not there. Now p cap x cap is, or we can say that if p cap x cap acting on psi is equivalent to I h cut minus I h cut acting on psi, or we can say p cap x cap is equivalent to or equal to I h cut minus I h cut. Okay, so this is the result, or this is the commutator for p cap and s cap. Now if it is commutator for s cap and p cap, what will be commutator for x cap and p cap? I mean, we have now p cap x cap is equal to minus I h cut. Okay, so what will be x cap p cap? You know that this p cap x cap is just p cap x cap minus x cap p cap, and this will be right like x cap p cap minus p cap x cap. Okay, so from this we can write that, see, this is just the order is just opposites. Okay, so we can write p cap x cap is equal to minus x cap p cap. Okay, so yeah, but we know that, or we can say x cap p cap is, remember all this momentum is only on x axis, or p x cap, this will be minus of p cap x cap, but we know this p cap x cap is minus I h cut, so it will be I h cut. Okay, so today we have two results. One is x cap p cap, commutator of x cap p cap is equal to I h cut, and the other is p cap x cap, commutator is equal to minus I h cut. Okay, now let us come to the expression we were discussing. What was that? Yeah, we had this expression x cap plus x cap by x naught plus I p cap by p naught times x cap by x naught minus I p cap by p naught is x naught square by x cap square by x naught square plus p cap square by p naught square plus I by x naught p naught p cap x cap, right? So what can we write here? So now instead of p cap x cap, we can write minus h cap, right? So we can write x cap by x naught plus I p cap by p naught times x cap by x naught minus I p cap by p naught as x cap squared by x naught squared plus p cap squared by p naught squared plus I by x naught p naught, and p cap x cap is what? Minus h cut. Okay, so now just take this minus term will come here, so it will become minus. Now there are two i's, so I square divided by x naught p naught h cut. Okay, or what is I squared? I squared is minus 1, so this will become plus. So x cap squared by x naught squared plus p cap squared by p naught squared plus h cut by x naught p naught. Okay, Do we know value of x naught p naught? Yes. What was x naught? It was 2h cut by m omega, and p naught was root of 2 m omega h cut. Okay, let me calculate it here. So what will be value of x naught p naught? X naught p naught will be, see, both of them have the root over them, so we can take a big root, then 2 m omega h cut into 2h cut by m omega. Okay, so m omega will get cancelled, so inside we have 2h cut into 2h cut, so and root of that, so it will be 4h cut squared, root of 4h cut squared, which will be just 2h cut. Okay, so if this is 2h cut, now we can substitute x naught p naught as 2h cut, but that 2h cut, in that 2h cut will get cancelled out. Okay, so we will have only 1 by 2. So this expression will become x cap squared by x naught squared plus p cap squared by p naught squared plus 1 by 2. Okay, so we have finally got what we were looking for, or we can say x cap by x naught plus I p cap by p naught times x cap by x naught minus I p cap by p naught is what? X cap squared by x naught squared plus p cap squared by p naught squared plus half. Okay, so we were expecting, or in the case of real numbers or numbers, we were expecting it to be just a square plus b square, but it is not, and we found that in case of the special operators x cap and p cap, this will be x cap squared by x naught squared plus p cap squared by p naught squared plus half. Okay, but what was our Hamiltonian now? Hamiltonian was h cut omega x cap squared by x naught squared plus p cap squared by p naught squared. Okay, see now, so we know that we cannot write it like this because there is an extra term, but still we can write it using this. How? Just subtract a half from it. Okay, if you subtract half from it, you will get this term here. Okay, so from this we know x cap by x naught plus I p cap by p naught times x cap by x naught minus I p cap by p naught minus half will be equal to x cap squared by x naught squared plus p cap squared by p naught squared. Okay, so we can rewrite our Hamiltonian as h cap is equal to h cut omega I p cap by p naught times x cap by x naught minus I p cap by p naught minus half. Okay, now we have our Hamiltonian in a new form. Now we will call, see, to make it short, we can name this with something, right? So we will call this expression a cap, and this one we will take it as a cap dagger. Okay, when this symbol is put over a operator or matrix, we will call it dagger. I will explain it below. I will explain soon. Okay, for the time being, just assume this is just a symbol for this. Okay, then what? How can we rewrite this? So Hamiltonian will become h cut omega. This will be just a cap and a cap dagger, right? So a cap dagger minus half. Okay, now we have a simplified form for our Hamiltonian, and remember we have defined a cap and a cap dagger as what? A cap is x cap by x naught plus I p cap by p naught, and a cap dagger is equal to x cap by x naught minus I p cap by p naught. Okay, so this is our new form for our Hamiltonian. Now I am going to explain more about this. Okay, so this is actually called, see, when you look at this, it looks like some complex conjugate, right? but the conjugation happens only for this I. X cap and P cap and P naught and X naught remains the same, so they have some relation. Okay, and actually this is called Hermitian conjugate, or sometimes simply conjugate. Okay, now I'm going to explain on that. Let's see what is Hermitian conjugate, or maybe we can do it in next video. So let me stop here. So in next video I will be explaining Hermitian conjugate. Hermitian conjugate of an operator. Okay, so let's stop here. Thank you for watching.